want to do that last example here because I think that's going to be hugely helpful. And then we're going to go to that last page. $15. Now, this problem isn't exactly like number 1 from yesterday's assignment, but the biggest thing that trips people up is in this problem. First thing I notice about this proof is there is a congruent, and it's congruent angles, and they're the 3-letter names. The 3-letter names, I know, tend to mess with people. The key thing to remember about the 3-letter names of an angle is the middle letter is the vertex. The outside letters tell you where the sides go. So, P is the vertex. Goes towards S, goes towards Q. That's this angle. Could they have used the single letter name? Yeah, but they didn't. SRQ. R is the vertex. Go towards S, go towards Q. That's this angle. Got one congruent down. How many do I need in these proofs again? 3. Angle, side, angle, side, angle, side, angle, angle, side, 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 side. All of them require 3 congruents. So, I see a word. I see a word bisect. Now, our green postulate sheet has a lot of information from old postulate sheets on the top. Bisect shows up in 2 different places. It shows up here. It shows up here. You have to determine, is it an angle bisector or a segment bisector? The second part of bisect is always going to be the thing that tells you. If you are struggling to know that, there is a reason that I told you guys to keep your orange postulate sheet. You can always use these as examples to reference back to. Bisect. This is an angle bisect. Def, angle, bisect, or bisector. When you're dealing with angle bisectors, when you're dealing with anything with words, pay attention specifically to the things it talks about. It talks about the segment SQ. It talks about the angle PQR. PQR. In other words, I'm only focusing on the part of the picture that looks like this. I look at nothing else. Now, since this is a definition of angle bisectors have 2 congruent angles. If I look just at something that looks like this, do you see 2 angles that look to be about the same? Yeah. That one and that one? Yeah. Okay, back to this picture. This one is this one. Can I use the single letter name or do I have to use a 3-letter name? Have to use a 3-letter name. Angle. Q is the vertex, so Q's got to be in the middle of the name. This angle goes towards P and goes towards S. So P and S are the outside letters. Congruent to angle. Q is the vertex, goes towards R and goes towards S. Q has to be in the middle. And I mark them as congruent. Make sure you're doing a double angle mark this time. We've already got the single angle mark taken care of. Okay. Took care of words. Are there symbols? Congruent symbols, but we like them. Do we do algebra in these? No. Do we do substitution or transitive? No. We look at a picture? Yeah. only two things you can get out of a picture. Either vertical angles or they share a side. They share a side. What's the name of the side? The property is reflexive. Thank you. The side. It's now a side. The side that is shared has what is a name? QS or SQ, whichever you use. Reflexive property says you could say it's congruent to itself. It's essentially saying QS in one triangle is congruent to QS in the other triangle because they're the same. And now I need to match up. Look at one of your triangles. Look at the congruencies on it and ask yourself, does it look like this triangle? Like that one? Like that one? Or like that one? And I'm not talking about the actual shape of the triangle. I'm talking about what markings are on it. Are the markings on this one matching which triangle? Which one? Well, I was about to say, my fingers are on a lot of them. 1, 2, 3, or 4. Think it 3? Now, I like that you're seeing multiple angles, but look at where the side is compared to the angles. It's between. Is it between on this one? If the angles are here and here, the between side would be that one. Is that marked as congruent? No. But there are 2 angles. This side's not between, that's this one. Angle, angle, side. Okay, that example is a great one to have in our notes. The other thing that I said we're going to fill out today is that last page, that thing that gives us the hint on how to do all of these proofs. Flip to the last page once you've got this down. I'm just kind of basing on how people are writing to know when I should flip. Okay. Cash, I'll get you caught up on this proof during work time. Okay, so the last page kind of gives us the overview of proving triangles are congruent altogether. Reasons that you can say you have congruent triangles include the side, angle, side, 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 angle, side, angle, and angle, angle, side. Those are the reasons that we say that the triangles are congruent. The statement is the triangle blah, blah, blah is congruent to triangle blah, blah, blah. And the reason would be one of those 4. You've seen us do that a lot in these proofs. But when it comes to these proofs, the process of going through them always starts with the given. We should know that by now. And then we kind of go through looking at what do we have, what do we need to have. This is what I mean by this is kind of what my brain goes through when I'm marking up my picture. What do I currently have? How many congruencies do I have? How many do I need? And then we go through our 5 things. There are only so many things that come out in our 5 things. One of the words is bisect. Bisect could tell us that we have congruent angles, or it could tell us we have congruent segments. To know if it's congruent segments or if it's congruent angles, you look at the second thing. The blank bisects blank, that second thing tells you if it's angles or if it's sides. Other words that you will come across. Midpoint. The moment you see the word midpoint, you're getting some congruent segments out of it. Generally, you're going to see a picture that looks something like that. Those are the segments that are named congruent. It's those two right next to one another with that midpoint in the middle. The last word that really ever shows up in these proofs is the word right angle. When you have right angles, you're going to get congruent angles. And this one, people tend to forget what they're using. It's the right angle congruence theorem. Then on our proofs, we move on. We look for symbols. Symbols we're going to see. Have you noticed that there's really only two symbols that tend to prop up in our proofs? Congruent. We want these. These make us happy. And parallel, which will give you congruent angles. Now, parallel shows up in three forms. This is generally the thing that helps the most about this page, is the parallel, because I know the parallels are probably the hardest part of what we do in this. Parallels. Sometimes you'll see pictures like this, where this is parallel to this. Sometimes you'll see pictures like this, where this is parallel to this, or sometimes this goes to this. And sometimes you'll see pictures like this. Technically, they could tell you these are parallel, or they could tell you these are parallel. If they give you this type of picture, you are going to use the alternate interior angle theorem. It will say this angle is congruent to this angle, or it could say this angle is congruent to this angle. Alternate interior angles will tell you both of those in this situation. This picture is one that becomes a little trickier because it depends upon which sides they say are parallel. In this picture, it's still alternate interior angle theorem that you would use. But if you have a situation where they say HR is parallel to QS, I needed more room for this. I'm sorry I didn't give you as much room as we would like. It would be angle HRQ is congruent to angle SQR. If, on the other hand, they had told you these ones were the parallels, where HQ was parallel to SR, the angles that would have been congruent are this one and this one. Angle HQR would have been congruent to angle SRQ. So you gotta be careful on which ones you see there. If it is easier to only look at one, I'm not gonna even mark these angles on this one, just so you can only see the one pair of angles on this one. Like this one gives you technically both, so that one I'm not worried about. This one is picky one or the other. This one, on the other hand, is not alternate interior angles. These are both an alternate interior angle situation. This one's the corresponding angles postulate. If they give you that CD is parallel to YB, then it's this angle and this angle. Angle D is congruent to angle YBZ. The other situation would have given you this angle and this angle. That one shows up very, very rarely. I'm not going to give you the actual written out version of that one because it's following the same idea. Okay, last thing that we're going to fill out are these two. The things you get out of pictures. We've talked about this a lot. There's only two things you get out of pictures. Shared sides or angles. That's when we use our reflexive property. Otherwise, in the picture, you see situation like this. That's vertical angle theorem. It's angles that are congruent at that point. Make sure you use the three-letter name. I'm hoping this helps going through your proofs. It just gives a little bit more like bulleted list of these are the things I look for. I need to make that parallel area better in the future. I'm sorry about that. Okay. I already told you kind of the other part of what was going on today. I am giving you an extra credit worksheet. This extra credit worksheet is due on Friday. Extra credit, I do not take late. It is due on Friday. It's got to be turned in on Friday. Or early, but not late. If you choose to just simply work on your homework, there's no judgment on that. But please use your time, work on your proofs or your earlier worksheets. Because remember, our test that is coming up on Tuesday and Thursday next week is not all proofs. There's the Solvi triangle stuff in there too.